Hey guys, today we are looking at the second part of the sequences test, the Calc section. Again, there is no particular order to the questions that I'm doing them. It's not from the start of the topic to the end of the topic. It's fairly random. I'll try and demonstrate my thinking, and there'll be timestamps in the description. Let's get started. Question 7, we've got consider the sequence 1, negative 3/4, 9/16, negative 27 on 64, and we have to decide whether the sequence is an arithmetic progression, a geometric progression, or neither, and explain why we're thinking this. So, I am first thinking, well, an arithmetic progression has a common difference, and because this is bouncing between positive and negative, that's pretty unlikely. Is it a geometric progression? Possibly. Okay, I'm pretty confident the top is going up by 3 and that the bottom is going up by, the top is going up by multiples of 3, 3, 9, 27, the next one would be 81, right? The bottom one is going up by 4s, multiples of 4s, 4, 16, 64, and then 256, I believe. So I can be pretty confident it's a geometric progression, and so what I'm going to talk about is that there is a common ratio of negative 3/4, and it's negative because it's got a balance between positive and negative, times by negative 3/4, I get to negative 3/4. If I do, I'll go on this calc section, I go negative 3, try that again, negative 3/4, and I am timesing by negative 3/4, 9/16. That seems right. 9/16. Cool. So, pretty happy there. Times by 3 on the top, times by 4 on the bottom. Yeah, common ratio of negative 3 on 4, so it is geometric. I'm sure that actually answered the question. Geometric, there's my explanation. What is the exact value for the next term of the sequence? So exact value, I need to make sure that I have an actual fraction of some sort. I don't want to get the decimal, so I'm going to take, and I'll do negative 27 on 64. I'm going to multiply by negative 3 on 4. 31 on 256. Cool. Write down the general rule for the sequence. Okay, so general rule is the non-recursive rule. So if you remember from the non-calc section I spoke about, this we are, I'm just going to spot, non-recursive rule, we want Tn in terms of n. Okay, whereas the recursive rule is Tn, well, the next term in terms of the previous. So if it is geometric, which we've shown here, then it's got Tn is equal to a to the power of times r to the power of n take 1. And we know that a is equal to 1, r is equal to negative 3/4 from part 1 of question 7. So Tn is equal to 1 negative 3/4 to the power of n take 1. That's it. It's 1 mark. Not any need to go any further with that. Question 8. The nth term of sequence is defined by Tn is equal to n over 2 plus 4. This is my non-recursive rule. It doesn't have Tn or Tn plus 1 on both sides. So what term has a value between 126 and 127? Now, my best guess would be, because I am counting by halves here, that Tn would eventually become 126.5 rather than any other number. Okay, and I could solve this algebraically if I wanted. So 126.5 is equal to n on 2 plus 4. But if you're a little bit unsure, you might go to your Calc and solve this. Menu 3.1, solve 126.5 is equal to, I'm just going to use, I'll use n, why not? N over 2 plus 4, and I'm trying to solve for n. N is equal to 245, so T 245 has that value, that is the value between 126 and 127. Next part, we've got express Tn plus 1 in terms of Tn. So now we want the recursive rule. We want Tn plus 1 on the left-hand side, and then something to do with Tn here. Okay. Well, let's think about T1 first. What's happening at T1 is n becomes 1. Okay, so I'm looking, whoops, I need to make sure you guys can see this. That's what I've been writing. Tn plus 1 is equal to Tn. Okay. T1 is going to be my first term, which is an important part of my recursive formula. It's one of two parts. And it's going to be, when n becomes 1, half plus 4, so I get 4.5 or 4.5. And what about the next one? If I do 2 over 2 plus 4, then I've added another half, it becomes 5. Okay, now I'm thinking, what's that pattern involved in adding 0.5? Maybe I can check it again with 0.3. 1.5 plus 4 is equal to 5.5. Yeah, I can be pretty confident that I'm adding half with each step. So Tn plus 1, capital, lowercase, doesn't super matter, is Tn, I guess it will use capitals, plus 0.5 or plus half, where T1 is equal to 4.5. Okay, because I've got to make sure that I have expressed this part here. Cool. That's question 8 done, I believe. Yeah. Question 9. New road is 85 kilometers long and is being laid. At the end of stage 1, 35 kilometers of road has been laid. It took 45 days to complete stage 1. Stage 2, covering the remaining 50 kilometers, an extra 600 meters of new road is completed each day. Okay. Over the remaining 50 kilometers, I'm sure that's going to be useful information. An extra 600 meters new road is completed each day. Okay, and we've got 35 kilometers of road have been laid in stage 1. Just trying to highlight some of the important information that I can see. 85 kilometers long is the other important part. We might come back to this 45 days a little bit later as well. Let's find out. Let Tn be the length of road completed at the start of the day n at stage 2. So at the start of day 1, what is sorry, just a sec. Just don't want to steer us astray, so I'm double checking. At the start of day 1, how much road has been completed at the beginning of stage 2? Okay, well, 35 kilometers of road have been laid. and then stage 2, or when stage 1 was completed. So stage 2 starts at 35 kilometers. And then what is this pattern that we're doing to get the next day? Well, it tells us an extra 600 meters of new road is completed each day. We're not multiplying, we're just adding. But because this is in kilometers, we want this to be in kilometers also, 0.6 kilometers. So I'm taking the previous day's completion and I'm adding 0.6. That's it. Starts off at beginning of day 1, 35 kilometers. Find how long it would take for the entire road to be laid. Well, for the entire road to be laid, we've got stages 1 and stage 2. Stage 1 we know took us 45 days. Stage 2 we're not sure about. We still need to find this bit of information, but we do know that a new road is 85 kilometers long. That's when it finishes. Sorry, up the top here, 85 kilometers long is where it needs to finish. So when does our term here become 85? We might need to use our non-recursive rule. So Tn is equal to A, 35, plus intake 1 of D. My common difference is 0.6. And we want to know when it gets to 85. So I'm going to take 35 from both sides, and I get intake 1 times by 0.6. Because it's times by 0.6, I need to divide by 0.6. Now, we could probably do this using fractions, but we might just jump to the calculator just in case. 50 divided by 0.6. I was really hoping it would give me a nicer number than that, but that's what it is. N is equal to, n take 1 is equal to 83.33, or a third, 83 and a third. And then we need to add 1, so n is equal to 84 days. This is only part of the question. At the moment, we've just shown that it's going to take 84 and third days to complete stage 2. So, because it's going to take a bit more than 84 days, I would suggest we round to 85 days. 85 days for stage 2 plus the 45 days for stage 1, and we get 130 days total. Cool. Seems like a lot to mark, but essentially what we've done is we've used our non-recursive rule, okay, which we can use in our calculator. We didn't have to do all the algebra, if I'm honest. We could have just used the solve function in our calculator. We had to round up because it was running into the next day, and then add stage 1, which was in the beginning of the question, and we're going to. Cool. Stage 2, sorry, not stage 2, question 10, much better. In 2005, a recycling center processed 2,000 tons of plastic containers. Excuse me. The amount of plastic containers processed each year increased by 8%. Okay, increasing by percentages is going to immediately lead us to think about geometric sequences. Okay, because we're increasing by a ratio of 8%. Let AN be tons of plastic containers recycled for the year, where N is the number of years after 2005. So if N is 0, it is 2005. If N is equal to 1, than it is 2006. All right, number of years after 2005. 1 year after 2006. Write a recursive rule for the amount of plastic containers recycled. So we need a recursive rule. So we want Tn plus 1 in terms of Tn. You didn't really have to use T, but I just tend to stick with what I know, or the same kind of idea. It's increasing by 8%. So increasing by 8%. All right. Got my 100% plus my 8%, making 1.08 times the previous year's amount. Okay, because it's processing an extra 8% every year. Not quite done with our recursive rule yet. We need to make sure that we have T1 or T0. Because this is a time since number of years after 2005, the time since 2005, I would really recommend that we use T0 because at the beginning of the 0th year, it is 2000. Okay. If you were to use T1, you would want to make sure you've increased that by 8%, so that T1, n being the number of years after 2005, this is the amount of plastic recycled in 2006. So you're allowed to use T1, but you need to make sure you've interpreted that n correctly. Okay, and that's generally where people are going to go wrong. They're going to say T1 is equal to 2000. And then that's going to lead to mistakes a little bit later, or in this next part. In which year would the recycling center for the first time recycle more than 5,000 tons of plastic containers? Well, this seems like a lot to figure out at once, but if we use our lists and spreadsheets, we can make this a little bit better. And so in 2006, which I'll put in row B, okay, we could start with 2001, but I think it's going to be easier to match up the numbers on the left-hand side with the n value. So when n is equal to 1, it is year 2006, and we have 2,160. Okay. Just for simplicity's sake, when we're reading it a little bit later, if you wanted to start with 2000, you would need to make sure you've adjusted for that. So you would need to add or subtract 1 to your n value at some stage. Probably take 1. Regardless, that's why we've done this, so we don't need to think as much about it. My next number is equal to a 1 times by 1.8 times, it doesn't matter which order we're doing it in, and that's 2007, or B1 plus a year. So I'm going to click and drag these down. I don't know how long it's going to take, so I'm just guessing here. And where does it hit 5,000? My question. This is the first time we've got T11 on 2016. T11 is equal to 4663. T12, however, is 5036. So, in which year would the recycling center for the first time recycle more than 5,000 tons of plastic? It is 12 years after 2005, or in 2017. So, n is equal to 12, so this means it is 12 years after 2005. And because we're asking in which year, we need to actually express. This is year 2007. Okay, we are about halfway through this at the moment. Just trying to explain this as carefully as possible. hopefully it's beneficial. Question 11. Arithmetic sequence has t22 is equal to 22 and t26 is equal to 12. Find the simplified general rule. Okay, again, this means my non-recursive rule, in case you are unsure. For an arithmetic sequence. Now, there's a few different ways to do this. If it were a non-calc section, then we would need to do it algebraically, but because this is a calc section, we don't have that issue, so we can use simultaneous equations. So I'm going to set up two equations, one for t22 and another for t26. And we're going to use this general rule for an arithmetic sequence, which says that Tn is equal to a plus n take 1 d. Now the only thing that we know about in t22 and t26 is n, because we're trying to find a and d. In this case, we're just going to go a is equal to n take 1, which is 21d, and this is going to be a is equal to a plus 25 times d. That is d, not cl. My d's tend to look like cl. Now we've got two equations, two unknowns, and that's going to lead us to simultaneous equations. Before I get straight into that, I just want to mention that there is 4 terms difference, so there is 4d difference between each of these terms, and a difference of 10 between them. So if I was doing it algebraically, I would know that 4d is equal to minus 10, because it's got to decrease from 22 to 12. Okay, and so I'm expecting negative 2.5 to pop up when I solve these simultaneous equations. Okay, back to my calc section. I'll just clear my history so it's nice and clear. And I am trying to solve simultaneous equations. So in my algebra section, solve a system of equations. They are both linear, but it probably doesn't matter which one you go to. Solve a system of linear equations. We've got two equations, and we've got the letters A and D. And you don't have to change that, but I'm just changing it so it's a little bit clearer. Sorry, I haven't quite finished my equations. I've got to go back. T22 is 22, so we've got 22 is equal to A plus 21D. That's my first equation. And I've got 12 is equal to A add 25D. There's my second equation. I had to replace these two numbers in with these ones. Alright. Now let's go back. Now that I've got the actual equations. 22 is equal to A plus 21D. 12 is equal to A plus 25D. Well, fractions might not be our best friend at the moment. There it is. Okay. Follow the calculator. A is 74.5 and D is negative 2.5, which is what we were saying before, wasn't it? D was negative 2.5. I've opened it up. Again, don't want to do that. That's better. Now we've got to fill in the general rule. So Tn is equal to A, which we said was 74.5. Add n take 1 times by negative 2.5. And it does tell us in the formula, or in the question, that we want to simplify this general rule. So we have to expand my brackets. 75.5 add, scratch that. It's going to make that common mistake I've mentioned. We're timesing this negative 2.5 by both of these numbers. Negative 2.5 times by positive n is negative 2.5, and negative 1 times by negative 2.5 is positive 2.5. Next is 77, take 2.5, and is Tn. That's my final answer. Okay, simplified, expanded. Okay, and if you want to, because we have the ability to, we can quickly check it. If I put 77 take 2.5 times 22, we said T22 was 22. Cool, it works. We can be pretty happy with that answer. Okay, math has a lot of backward steps, so you can usually check your answers during a test, which is kind of a useful thing. Question 12. A plasma TV costs $3,000 and John decides to borrow all of the money at a rate of 12% compounded annually. So compound interest is increasing my loan. This is a 12% increase. R is equal to 1.12 instantly. He agrees to repay $500 at the end of each year until the loan is repaid. So it increases by 12%. Then we're subtracting 500 because we're talking about how much he owes. What is the recurrence rule that determines how much is owed after n years? So he starts off by borrowing $3,000 T, and I would recommend probably after n years. This is time since again. T0 is $3,000. Okay, because after 1 year, that amount's going to change. And we need a recurrence rule, so we need Tn plus 1 is equal to, my value is increasing by 12%, but I am taking 500 at the end of each year. So in the year it increases by 12%, then I'm taking my 500, and it all starts out at $3,000. Cool, that might be worth more than 1 mark, but oh well. Find the amount owing after 2 years. Okay, well, I'm going to go straight to the calculator in my sequences page. So I'm just going to open a new page, spreadsheets. So this amount, T1 is going to be equal to 3,000 times 1.12, take my 500. Okay, it's increased by 12% and take 500 after the first year. As I mentioned earlier, matching that term number to the left-hand side is going to result in less confusion later on. Okay, so T1 is equal to 2,860. I'm setting this up in list and spreadsheets because I know I'm likely going to have to use my list and spreadsheets for a later question. You could plausibly do this in the calc section as 3,000 times 1.12, take 500, there's my T1. Now I'm going to take this answer, times by 1.12, take 500, there's my T2, but again, I'm going to set it up, 1.12 times A1, take 500 in here, because I'm likely going to have to do more with this. This is in the second part. T2 is equal to 2,703.20. How many years does it take to pay off the loan? There you go. We need to make sure that this results in 0 at some stage. And I'm not sure how far it goes. Clearly it's a lot less than 20 years. There is the first number that is less than 0. So T11, he still owes money, still owes $108.36. But in T12, he owes much less than that. In fact, he shouldn't have paid that full repayment on the last time. So how many years does it take to pay off the loan? 12 years. All right. But in his final repayment, okay, this is where we kind of arch off here. He doesn't need to pay the full $500 in here, does he? Okay. He needs to pay. Let's actually bring up my scratch pad. If I do 500, take the 378.64. That is my final repayment. Final repayment is $121.36. The other way to get that is if I was to take my answer, close the scratch pad now, the 11th year, he still owes $108. So before he finishes paying it off, he needs to pay the interest on that $108 still. So A11 times 1.12. He's not going to pay the full $500. He's just going to pay what remains after the interest has increased his loan. All right. So two different ways you can get the same answer. Final repayment is $121.36. Okay. That stuff's hopefully going to make a bit more sense when we hit the finance section at some stage. All right. Oh, geez, we still got lots more. Question 13. Harold starts a new job on the 1st of January 2005 with a yearly salary of $48,000. His contract includes an annual pay rises of 12%, effective from the 1st of January for the next 10 years. So what that means is that in 2005 he's getting $48,000. Okay, but in 2006, after the 1 year has been completed, okay, then we're going to be getting 12% more than that. Now, what would be the salary in 2010? What might be useful is to have some sort of recursive rule here. Tn plus 1 is equal to 1.12 lots of Tn, where T0, again, this is a time since question, right? Time since January 2005, after 1 year, it's increased. So after 0 years, it's still the $48,000. All right. Or if you would prefer a non-recursive rule, 1.12 power of n. Okay. When you start with a T0 situation, the recursive rule changes, both arithmetic and geometric. That n take 1 disappears and just becomes n, or the take 1 disappears. So we do not want this take 1 here, because we've started with T0. So 5 years later, it is increased. 5 years later, in 2010, there's been 5 increases. Okay, 5 increases, 1.12 to the power of 5. This factors in, so it works a little bit. T5, 5 years after, 48,000 times by 1.12 to the power of 5. Or, again, you can do this on the list and spreadsheet section if you understand what's going on. Alright, starts off as 48,000 after 1 year. It's increased a bit. Okay, and 2 years, it's increased again. And we want up to 5 years, or if you would prefer, 48,000 times by 1.12 to the power of 5. Same value. T5 is equal to $84,592.42. Same number. Cool. In what year will his salary go above 95,000? This is why the list and spreadsheets section is helpful, because we're going to increase again until we get above 95,000. This is below T6 is $94,743.50. T7, however, is $106,113, and I'm sure there's somewhere where we can see more values here. I forget how to do that at the moment. Not to worry, because we just ask them what year. In what year? This is 7 years after. 7 years after. 7 years after. So 2005 plus 7. It should happen in 2012. And if you're a little bit unsure, you can do this on the side. This was in 2006, from January 1st, 2006, it got increased. And then we're doing every year after this one here. So there are other ways of doing the sequences on your calculator. This is just what I like with the list and spreadsheets. So there it is, 106,113 for 2012. We can be pretty confident that is in case the answer. Final question, number 14. This graph is an exponential. This clearly states what type of sequence it is, because remember that exponential implies a geometric sequence. Linear, on the other hand, is arithmetic. So we need to keep this geometric idea as we go through. Now, we really can only be certain about 2, 9, and 4, 10.1. And these are the number of terms. So this is T2, and this is T4. Part 1, we're talking about state the recurrence rule for the plotted sequence above for whole values of n. So if we're doing a recurrence rule, this is Tn plus 1 is equal to something Tn. We need to know what this R value is before we can do it. And I know it's an R value because we already told it's an exponential, so it must be geometric. It must have a common ratio. Okay? So if you would like, what we can use is the non-recursive rule and explain or describe T2 and T4, which we know is 9 and 10.1, in terms of A, which we don't know. Okay, first term, we're not sure, it doesn't tell us. Okay, R, that's what we're trying to find, but we do know that n take 1, n is 2, 2 take 1 is 1, and n take 1, n is 4, take 1 is 3. So we have 2 equations, 2 unknowns. Okay. Otherwise, we have 2 terms difference, which means we have a difference of the common ratio, but it's done twice, and this would be my T4 on T2, or 10.1 on 9 is equal to R squared. When we have an R squared value, you're going to have a positive and a negative solution. So we need to actually state both possible ideas because they're both possibilities. Let's do the simultaneous equations in here. Okay, it is no longer a system of linear equations because we've got R to the power of 3. Let me just clear my history here. We're going to go menu, solve a system of equations, not linear though, and we've got A and R. 9 is equal to A times R, and then 10.1 is equal to A times R to the power of 3. Okay, so it gives me two solutions. R is equal to negative and positive here. Negative 1.05, positive 1.05. And your A clearly changes along with that. So, state the recurrence rule. Alright. We need, and I'll do it down here because I've run out of room there. This is still part I. Our recurrence rule is Tn plus 1 is equal to, we know that R is equal to plus or minus 1.05. I'll just go to 2 decimal places. You could probably go to more. And we know that A is equal to plus or minus 8.53. Sorry, I've been steering you a little bit wrong up until this point. We know by this graph, because it is actually an increasing exponential, that R has to be positive rather than a decreasing exponential, R would be negative. So scratch what I've said a little bit down here, it is just 1.05. And with that solution, we have positive 1.05, A is equal to positive 8.53, or 8.54 to 2 decimal places. .05 Tn, A is equal to 8.54. Okay, you could go to more if you wanted to. If you didn't want this solution, you can actually use this for button in the blue part of your equal sign for R is greater than 0. It would only give you the one solution. It doesn't happen much in Year 12 apps, but it could be a useful thing to know. Anyways, that's my recursive formula. Okay. Sorry, T1 is equal to 8.54. If you wanted to, you would actually get T0 is equal to 8 by going back another term. But we don't really need that so much. Another sequence has a recurrence rule. Tn is equal to Tn take 1 plus 2. So I've got a common difference of plus 2. T1 is equal to 5. So T1 is 5. Plot the first 4 terms from the sequence on the graph and draw a dotted line connecting them. Give the coordinates where the resulting line intersects. This is why a ruler is handy anytime you're doing your exams. Okay. T1 is 5. Alright. Do it rough. That should be T1. T2 is going to increase by 2. So let's say it's roughly there. T3 again is going to increase by 2. Roughly there. T4 increase by 2. 9 plus 2 is 11. Alright. Not perfect, but it will do. 1, 5, 2, 7. Doesn't say plot the points, but that's what's going on in my formula. Alright. And if I'm going backwards too, and that's a little bit tricky to see, I'll try and turn the page a little bit more. It says draw a dotted line connecting them, and then get the coordinates where the resulting line intersects the vertical axis. So I'm going backwards. through here, it's supposed to be dotted line, right? Cool. 2 backwards from term 1. If I'm adding 2 going up, then I'm taking 2 going down. This is coordinates 0, 3. And then we're done. Hopefully that helps. Again, timestamps are in the description. I suppose it's not that useful at the end of the video, but oh well. See you next time.